All right, this is going to be a continuation as we progress through each chapter. I'm going to be kind of building on what we started last week. And just as a quick review, last week we built a savings class that inherited from account. And that inheritance idea you're going to be working towards as you progress and kind of getting an understanding of it. And of course, we'll be implementing some aspects of it through the videos. And what we did was we just created that savings class that is going to inherit from account with just some basic code just to utilize the data inside and protect it. So we have our prototypes that access your account, lower level account private data members, and then you inherit from it using the member init list. So and that comes in from the savings. So this is all from the last video. What we're going to do this video is we're going to actually implement a customer class, but what we're going to do is we're going to make it so you can load and save a list of customers, and more on that in a second, because I actually got to talk about your inventory assignment for this week, and some of the issues that most students have, or one particular issue in particular that most students have, and that is essentially, if we look at 162, looks like I'm going to have to pause. I've lost internet. Okay, I'll try to keep those little intrusions low, at a lower level as we progress. So let's see here. You have your homework assignments for chapter 11. No, not 11. It would be chapter 13, files. So you have your inventory program in here that you're going to be doing. This inventory program number using a binary file. Now, the thing about this is the inventory program has read and write access. That means you're controlling or you're keeping track of four, and I call them file pointers, but basically they're four references to locations in the file where you're saving to, where you're loading from, and also the pointers for saving and loading. So that's with your seek gets and seek puts. You're going to be using both versions of that for read and write. So the critical factor here is that the file actually has to exist before you can even work with it. Now there's ways around it where you can check to see if the file doesn't exist with an open create flag, but it's, as far as the type of program you're building, you're essentially building your own database. So what you want to do is, before you start writing code, is you're going to want to go to the folder where your CPP files, and let's just pretend that the folder we're working on is going to be what you're using for your homework. So this is like the folder of the project that we're working on for this video. What you're going to want to do is you're going to want to make sure that when you view that you have file extensions viewed or checked so that you can see file extensions. And then you're just going to want to go right click here and say new, and you can just do text document, and this will be your data, and essentially you're going to say, call it what you want, data or inventory, or INV is fine. And then give it a different extension than text, because it's binary, it's not going to be text readable. And then just call it .bin. And then what you'll do is this inv.bin file, you will open from your, when you use your file open code, you will just type in inv.bin within two double quotes, and you won't need to particularly point to a location like on C:\\/ my documents, etc. So it's called implicit file opening, and we'll talk more about that later on. But essentially, you probably want it in two spots just to be in case. I put it where the project is looking for files, and then I put it, where the executable will actually be looking for files. So I find the executable in the folder, and I put it there too. So one or the other will work for you. Now also note that you're going to have to erase this file. You're going to mess it up a couple times. So you're going to have to erase this inventory file that you're creating. Let me try to get back into there. So periodically when you mess up this file, you just have to delete it and recreate it and add inventory again. It's going to happen. It's part of learning. So that's the critical aspect of your inventory program. Make sure that your file is in with your CPP and your header source files. Just create it first and then start working on your code. Okay, now that we've got that out of the way, what we're going to do is we're going to continue on with creating or what I like to say is persistent objects. And that means that an object that you write the whole object out to file. In binary, that means that once you change the state of the object and write to the binary file, then essentially that object is persistent, or you can just load in that data into your object again and have it the same state as when you saved it. Meaning you can change the data, save it to disk, and have it changed from the disk and continue on working with it just like it was a database. So essentially you're creating your own database. And we're going to start that with a customer class. And I'm going to go ahead and just bring it right into this code. And what we're going to do is I'm going to go in line with this just to be quick. I've already shown you how to do your CPP file. So I'm going to and I've already written the code so we can just talk about it. So let's first talk about the customer code. And I have it up in another bit here. And what we're going to do is we're going to create this customer class. You can actually find this code in the module. I believe I still have it up there. Let's see here. This example code is called Customers Project 1.zip. And there's also a project starter in there you can look at, but we're kind of doing the project starter now. This is 2 bits of code. Let's go ahead and look at this customer object and look at what it's composed of. Now, the most important part of this customer object is it's appropriately created. As stated from my last video, you have a default constructor, and actually this is not completed. You should be assigning default values to this, and then we have this char first name array. Now that's where you were thinking, "Now, God, why are you doing that? You should use a string." Well, strings don't have a fixed length, so you can't use these for binary files. You can through what's called serialization that you can read about in your book. It has a serialization, how to serialize section. But for the purposes of what you're doing, we're going to start out with just a set fixed length character array for a name, and of course you're going to be adding last name and all that stuff. What we've done is we've built. We're going to add another set function that takes a string. So the components is a constructor, an overloaded constructor, and this constructor is just going to assign default values, which is essentially nothing to a first name. An overloaded constructor so that we can pass that in. A set ID, get ID, a set first name, a get first name, and then of course your print. So you would add last name and everything else that you needed for a customer. So I'm actually gonna just take this code and grab it, and I have it in another window. So I'm gonna create a header file over in the project that we started last week, and this is the project that we've been working on from the first video. And what I'm gonna do is I'm just gonna add another header file, new item, and we're just going to make a header file. We don't want any CPP because I'm going to go inline for this and not do an implementation file. Okay, we got customer.h here. Okay, let's add that in. Okay, let's get it in our code, and then we're going to make some modifications actually. So this customer class, one thing that I don't like about it is the fact that if we're building this as a tool, let's make it work better. And that is where we want the string. We want to be able to set a constructor for sending a string and an ID. That's the first thing we want. Control Z is your friend. Remember that. Okay, so we want to do this so that we have another overloaded constructor we can use instead of sending a C string, which is what we call those character arrays, a C string. We want to be able to send it a name. And this name, we're going to send it to the set name function. So that means that the string coming in needs to be converted to a C string. And the way we can do that is using the, I believe it's underscore C string or str, C underscore str. And what that is it's a function. And you can see it pop up here. It will return a C string. Oh no, it's not a function. It's a property. So it's the C string equivalent of the first name. Now, when we do a set first name, since we're now have the capability of, one thing that we want to do is we want to, this constructor will send in a string based on the first name, and that is a string type, and it'll push it down into the set name function, which takes on a C string. So right here, we just convert it to a C string. So this overload function is now good. But one thing we need to do is just for error checking, we need to do an if of string length, and this might be underscores, might be something that, but the string length of f name, if the length is less than the size of f name, which is going to be 100, then we return. Else we will actually do the string copy because we're not going over our limited size. Okay, so this might have some errors in it. No, it looks like it's good. I got all the right headers, it looks like. So now let's do this. Let's do a set first name, but let's do it so that we can send it a string. So we're going to go ahead and just grab this guy, and instead of char f name, we're going to do string f name. And now we can use different terminology because we're going to check the f name size. If f name dot length, and is that a property too? Yeah, I believe it is. So then we don't need the string copy now. We can just use the equals, and we can say this first name equals fname. I might have messed this up. Literally. Okay, so I don't think we need, yeah, we do, because it is, oh, duh, we do need the string copy. What am I thinking? I'm being silly. Okay. Okay, there we go. It's this guy that we are having an issue with. We need to send its string equivalent, the C string equivalent. Okay, so now we have a fully functioning, or pretty much a fully functioning customer class. We could return a string here. That would actually do it, pretty much everything that we need. So I believe that there is, you can do a get sf name, like get string first name, and return a string version of the first name, and do a conversion from a C string to a string, and you can do that with a string copy. Or some other tools, but I think we're going to go ahead and call that good for now. So that's a customer class that we can use, and what we're going to want to do is we're going to want to actually save this class as binary, or instantiate some items of this object and save it as binary. So what we're going to do is we're going to create another object to hold a list of customers, and this is going somewhere in the direction of your book. So I have that example code from that project that I showed you on in your canvas, and that is called customer list. And what this object is going to do is it's just going to hold an array of customers, and we're going to actually convert this to a vector of customers. And that way it's dynamic. And then what we're going to do is we're going to improve this a little bit, because this shouldn't be public. It should be a little bit more controlled. So we may actually end up, this is actually going to inherit from a vector of customers. So actually, you know what? We're going to skip ahead and just go ahead and do that. We're going to have it inherit from a vector of customers. That way, it's a little bit further along, and we're going to be creating a vector of customers, or your customer list will inherit the vector class and pretty much have all the capabilities of a vector class. And it's going to be a vector class of customers that we're going to hold. So we're going to jump ahead a little bit in some stuff, but this code as is works. You can create your array of customers and test it. So we're going to actually, I'm going to just demonstrate how this works, and then we'll convert it to the vector, or inheriting from a vector class. So let's go ahead and grab this stuff, and we're going to create a customer list object. And the customer list object, all it's going to do is give the capability of working with a binary file and having a persistent list of customers. And then if we have time, we might port it and make it work for an account list. So let's go ahead and grab this code, and I'm going to make a few changes here. But remember, this is not good code yet because of this public here and not having our customers and our customer lists private. I'm going to just test it, and then we're going to make a good code. This should actually be, we should have this public down here, and let's just fix it right now, and this private right here. Okay, that works. All right. No, now it's proper. Okay. So we're gonna grab this code now again, and we're gonna transfer it over to our project from our account project. So let's go ahead and bring it over here, and this is our account project from the video, or as we've been progressing our videos. So we're going to go ahead and go to the project, and we're going to add a new item, and that new item is going to be a header file, and this is going to be what we call the customer list object. Okay, now inside we have our customer list, and we're going to be talking about this as I test this. So essentially what we're doing is we're building this in a manner that you can basically have a persistent customer list. So when I save the customer list, what I'm actually doing is I'm opening up the customer's DAT file. Now this code, what's nice about this code is it's not for reading and writing. You don't really want to get in the habit. It's really a bad habit to do the old school method of files like the inventory program you're putting in. That is basically the kind of programming that computers did not have as much RAM and essentially back in the day what they did is they built programs that used very little RAM, and mostly they treated the hard drive like it was RAM. And that's what your inventory program is. Now the problem with the inventory program is if you were in the middle of reading and writing your crucial information to disk, oftentimes a computer would crash. Well, yeah, big surprise. And that file would get corrupted. So back in the day, before we had a lot of RAM, you had all these programs that were built to fix your files that you corrupted. So you're learning the old way of doing things with that inventory program, but we don't need that. We don't need to do that for this. So what we're going to do is pause real quick. Okay, sorry about that. For some reason, my Amazon show started up. Okay, so we're going to create this file so that it's only works with read and write separately. So what you do is you open up the file, and the way we're opening up this file is so it's open or create. So if it's not created, if the file doesn't exist, then it creates it for you. So that's one nice thing about this implementation is the way that it's done is you just do one at a time, output, and then when you load, you do input. And that's the better way of doing things than reading and writing from the file at the same time, because it causes lots of problems. So you want to kind of gauge, you're building your own database, the rule of databasing is you get in, you get out. You get in, get the information you want, as much information as you can, and you get out. So you open the file, do what you need, and close the file. With the inventory program, you open the file and you keep it open while you're working with the file, because the old school method, the file was your RAM, essentially. So that causes a lot of problems with file corruption because computers crash. And rules of information, that's the rule of thumb. You get in, you get out as soon as possible, because you don't know if another process wants access to that data that needs it, and they have not built a database yet that can handle multiple sessions at a time. It's impossible. We open the file for output as binary, and it'll create the file. Here is a key part of this save. This is going to save a customer the amount of customers that is in the list. So this is a file header. And this is very important because we didn't know how many customers are in the list, because we're going to eventually be making it so that, or actually today we're going to make it so that you can save dynamic custom, or save basically a dynamic amount of customers. The amount of customers can change, and we're going to do that with the vector class. And then for all the customers that we have in our list, the count of customers, we're going to output it, the customer itself. Now you see here, I like to go from the dynamic memory to a stack, a customer that's on the stack. It just makes things easier to work with. You can sometimes go right to the dynamic memory on the heap, but you're not going to, you're going to have some problems there with code. So I always go to the stack with what I'm writing to disk as binary. And when we write a customer out as binary, basically we are sending just the bytes of that customer, just the bytes of the customer that we're saving. And this right here where it says char star, and you're like, wait a minute, that's a cast. Why are we casting a customer to a char array? Well, you're not, because as I always like to state, and I'll kind of make fun of it, C++ is Frankenstein, because it's got so many dang band-aids and stitches. So what they did here is they know that this is just bits and bytes and it's untyped, and they know the size of it. So this is just a band-aid to make it work. And you just cast it, whatever it is, doesn't matter. You cast the address of that item that you're going to be saving, the object you're going to be saving to disk, to a char star as a band-aid for syntax. There's really, char star is, kind of ridiculous but that's why you cast this to a char star too. So basically what you're saying is output, or just give me the bytes of the data. And again, it's just it's a quirk of the language, and that's it's been updated through time so much. I'm sure there's another reason why, but it'd be interesting if one of you did some research and sent me an email on it. But quirks of the language. So it doesn't matter what data type what you're saving to disk is binary, because you're going to use this char star cast and basically throw out bytes, and that's all you're going to do. And then you tell the write function how many bytes you're going to save. So we're going to output an integer, and the integer is going to, or we're going to output data. Here's the address of the data we want to output and to the disk, and this is the size of how much information you're putting in the disk. And then we will output the customers itself. So let's give a little quick demonstration on what this file actually kind of looks like with a bit of a drawing. And I'm going to go ahead and pause it and come back. Okay, so this will be a kind of an example of the file. So our first 4 bytes in the file will be count. And that 4 bytes is going to tell me, and it's going to contain the value 3. And that value 3 is going to tell me how many customers are in the file. And the customers are all going to be the same size. They have to be. Unless you use serialization and you have different types of customers. That's dynamic binding, and that's later on in the course. So our first 4 bytes in the disk are going to be count. We read that in first. And then we know how many customers are in the file. So we read one customer, then in the next one, and then the next one for 3 times. So this is a file header. And a file header is used for complex files so you know the context of the file. And so these file headers can be kind of more complex because you can give it some other information in here that would kind of give you an idea of what is contained in the file if you did not have a regular file situation such as I do, where everything after is just customers that are the same size. And let's say that customers are 50 bytes. And so our first 4 bytes in the file is the amount of customers in, and then we read in each customer, And so with that in the code, our first bit is reading in the count. We know how much information or how many items are in the file. It's 3. And for 3 times, get the customers or save the or read the customers. Actually, I'm talking save. Output the count, and then output each customer the size of the customer, which would be your 50 bytes. So you would do that 3 times. So output your count in the file. This output right here on line 32 would do this part. And then 3 times, we would output the customers right here that are size 50. And they just come one after the other in the file. So it'll be easy to read. Okay, so let's go ahead and test this. And what we should be able to see is we should actually be able to look up the size of the file and see that, hey, we've got 4 bytes in there that represents our count, and we have customers in there, 3 customers in there that we can just multiply the size of customer. If you look at line 38, I'm already outputting it. And you would find it. And I always test my files and look at the size to make sure that it's what I expect. And you're going to want to do this too, because you're going to make mistakes. So now what I'm going to do here is, before I can load customers, I'm going to create the file and save some customers. And this is going to be code that I'm actually going to set a constructor for when we instantiate a customer list. We're going to actually do a step into this and look at this actually happening. In this constructor, it's going to change. We're not going to be actually doing this, but we're going to put it in here just to test it. And then we're going to save the data that we've created or initialized here for our 3 customers, and then we're going to load it. So let's go ahead and test this. Do we have our customer list in here? Yes, so we can go to our source and we can do a customer list instantiation. And our customer list, we need to include okay. All right, so we're going to set a breakpoint right here so I can step into it and kind of look at things that are going to be happening. Well, looks like we've got a few little issues. That should not be a problem. That is the problem. It looks like my little addition here does not like, so let's go ahead and, because you're going to be dealing with this, so we're going to actually fix this. Looks like basic string, non-standard using and to create a pointer to member. Set first name, F name, C string. Do I gotta send it the address? Yeah, probably. Let's try that out. Okay, we're gonna put this on the back burner. And we're gonna go ahead and come back. I'm going to go ahead and pause this and come back, and I'll show you the fix, but it's going to be a few things that have got to be fixed. I think this is length is a function, so that one is an easy one to fix. Okay, so here is string copy. Function does not take 2 arguments. and then this one. Oh, it's the same line of code. Okay, this line of code I'm gonna get fixed, and I will show you the solution. Well, I knew that was a function when I first started this. So yeah, so it's just C string with your parentheses. So that's a function. So I think we're ready to test this. I went ahead and built it, and we're good to go. We just had those two minor fixes. So let's go ahead and go back to here. And from our source, we're going to instantiate this customer list. And we're going to do a step into to look at the constructor and what it says. Okay, I'm going to do a step into. And what that's going to do is allow me to step over the code that's in here. And it looks like I set the breakpoint in the wrong spot. I want it to actually be up here. Right there. Oh, it's being a turd. Okay, I got to put it up one more. Okay, step over. That is not good. That means customer list is having some problems. I should be able to step into it, but okay. So let's just set the breakpoint in the constructor. All right. Looks like I got a few other issues to fix, and I'll be back. Okay. Well, I forgot, when you don't overload a constructor, you don't put the parentheses when you create one off the stack. So you just got to take out the parentheses there, and we're ready to test it. So I'm going to go ahead and set the breakpoint here. And we don't need one over here, but let's go ahead and get this running so we can kind of test it out and see what's going on. So I'm going to go ahead and hit start. And here is where we're going to do our step into. And now this is the customer list object, and it's going to go in and complete the constructor. We assign memory ID values to our customers. Then we save our customers. So I do a step into, and we're going to set the count to 3. Remember, that's going to be dynamic. Then we open or create customers.dat. Then we output the count. Then 3 times we output each customer. So you can see temp is going to be assigned a value coming off of what's going to end up being the heap eventually. So this is just an intermediary point. You can actually remove it to optimize. So we're going to save 3 customers, and then we're going to output the size of customer. Now this is going to be important so that we can look at our file and make sure it has everything that we expect. Then we're going to close the file, and we're done. And we come out, and we're done. Okay, so let's look at our output so we can look at our size of customer. It looks like size of customer is 104. So we should have 4 bytes for the count, and 104 times 3 customers bytes plus 4. Okay, so that is going to be, okay, yeah, I'm horrible. I just, I get lazy, and it is what it is. 104 times 3 customers, 312 bytes in the file from customers, and then 4 bytes for the count. So our file that we just created should be 316 bytes. So let's look at it. And here's our customer's DAT that automatically was created with our open or create. We look at properties, and it looks like we have 1 kilobyte. That doesn't look right. Well, maybe it did it from the executables location. So let's look at the executable location. No, it would have created it here. So look at properties. 1 kilobyte. It should be saying 316. You look at this one, and it looks like maybe I don't have my view set up correct. Because it's just saying 1 kilobyte, and I'm expecting a little bit more information. Size 2 kilobytes. Should be 316 bytes. Okay, I'm going to look into it, and I'll be right back. Yep, I was looking at the wrong folder. It was from the zipped, from the download up on Canvas. So this is where our customers.dat file got saved for the project we're currently working on. And notice how I didn't put like C:\/ or a place for the file, because I want the file to be implicit. So that means that it's saving implicitly to the only place that that the compiler knows exists, which is where the executable or the current directory the executable is running in. And this is the way you want to build programs, so that you don't hard code information to a specific folder location. Always do it this way. So it's now we can look at the size, and remember, I think it was 316. There's our 316 bytes. There we go. Okay, so we properly saved customers to file as binary. Now what we can do is we no longer need to generate this stuff. So let's go ahead and just comment it out. And we don't need to save until we change something. So let's go ahead and do a load. Now this load is going to just kind of work in reverse. It's going to read the information in. And it's going to get first the count. And then for the amount of customers in the file, so we really just go down the list. Line 48 reads in the count, your file header. Once you know how many items are in the file, then you know what for loop, how many times you need to run your for loop, or how many customers in the file. So then you read the customers in from the file, and essentially this line is not needed. Actually, this line needs to be changed. This is needs to be gone, so it's not needed. Okay, so, and you'll probably get rid of your couts in here because you'll have a print function for that. So for each customer that's in the file for count, we read them in. And these aren't 50 bytes. I just put that number in there. Actually, the 104 we saw. So pretend that 50 is 104, 104, 104. This is kind of how you want to build your own database, or at least the start of your own database or inventory program or way of saving your objects persistently, and it's safe to use. Now, serialization gets more complicated, and your book has information on that, and we're actually going to be progressing and making this more complicated, starting with first testing the load, and then I'm going to leave this update for you to play with. Now, this is an example of me updating and hard coding it. So this would be something more of you would not make it such hard, like this temp.set ID. You would actually you would ask the user for information. But what this is it opens up the binary file just like you do with your directory, and it follows the rule of thumb. Get in, get your information, get out. Get into your file, save your information, get out. Get into your file, update your information, get out. Don't do things like your inventory program. That is the wrong way to do things. You've got the RAM. Make your program so it does not corrupt. If you open up a file and you have that file open for the time that the executable is running, what ends up happening is your program would crash or stop, and the whole file would be corrupted. So that's why you don't do things that way. But you got to learn how to do things the wrong way before you learn how to do things the correct way. So this update function gets in and gets out, does not leave the file open throughout the whole process time of the executable. And this is an example on how to update your records. Now, we're actually not going to get into this because we're running up on time, and your inventory program should prepare you for it, and this example should give you something to work with that you can do. So obviously the file will exist by now for your input and output as binary. And the thing here is you got to manipulate 2 pointers. Your seek gets for reading information from the file, and your seek puts for outputting information to the file. They are 2 separate file pointers, one for getting, one for saving. That's your in and your out. Seek gets, seek puts. And you can change where you are in the file and essentially go anywhere in the file. You can do your seek gets and move the file pointer to a specific byte starting here and read in size of customer and get this information. You can do a seek puts, move the file pointer over here, update that information and output size of customer, and it'll just overwrite this section of the disk. So that's what seek gets and seek puts does, is it moves you around the file so that you can change these records. And that's why it's important that your size of is correct when you're reading and writing. Okay, now we get to have some fun. What we're going to do is we're going to convert this to vector class so that we can make it dynamic. Now this update function, we're not going to actually get probably working with the vector class until later on. What I want to do is I want to actually make this so that it inherits from the vector class. So customer list itself is a vector. And this is a little bit coming up. You're going to be learning about vectors coming up. And we no longer have a customer list inside because the list itself is going to inherit from the vector class. And we want a vector of customers. And now things really get cool because we have dynamic memory really easily. And we can use the vector class to deal with our stuff. And for our dynamic memory. Now here's the problem with the vector class in the standard template library. The vector class is dynamic memory, but its problem is every time you go over the size of your vector class, it'll actually take the whole array and recreate it, double its size, copy everything over. So that's where the vector class has a problem with when it comes to the dynamic memory, is because that operation right there is very inefficient and causes a lot of time constraints. And also, it's the vector class is a standard template and it works well no matter what program that you're working with for your operating system type. But it does have that little peculiar problem. Everything's in a contiguous array. So we're going to actually include vector here, I believe it is. I believe it's vector. Okay, so we're going to inherit, customer list is going to inherit from vector and customer. So this means that there's data inside the vector class that we're going to be using. So when we add to this customer list vector, we're going to be using like the push back, and we're going to be pushing customers onto that. So what we're going to do is we're going to take this code and let's cut it out, and let's go over here to customer.h, not customer.h, excuse me. We don't need any of this stuff that we're not really kind of looking at right now. Let's go to source, which is our main, and what we're going to do is we're going to create some customers on an array, and then we're just going to throw it into the vector. And that way you have something that will be able to change its size, and you can build a menu system to add customers, save customers, load customers, and you have the ability to save the customers in the vector that's dynamic and load customers from a vector that's dynamic, meaning the memory is not fixed. So we're going to actually test it with fixed memory though. So we're going to go ahead and create a customers array just for testing. We're going to fill that information up, but then we're going to do this step. since CList is now a vector, it's inheriting from the vector class, and we're telling it that it's storing customers. Customer list is a vector, so I'm going to use it like a vector. But here's the beauty of it. Customer list has the capability now to save the contents in the vector and load the contents into the vector. So it's really quite cool to do things this way. And in fact, your book shows you and starts getting you going in this direction when you talk about your chapter 5. I believe it's chapter 5 assignment that you got coming up. Oh, wait, no. That's 260. Excuse me. I'm talking CS 260. That will be coming up later. But this is the direction your book wants you to kind of go with your understanding that you have coming up for CS 260. So we're no longer going to load and save here. So this is going to, you're going to want to eventually load when customer list is created. So that is going to be a constant. But we're not going to have it just yet. So whenever the customer list is created, you want to load from file to get all your customers that you saved to file so it's persistent. So what we'll do here is we're going to have a viable file. Then we can start loading it automatically. So let's create our file first, and then we've got to change our save function. So we create our CList, and we're going to call it V customers. CList, customer list. CList dot, and this is going to be, since this is customer list inherits from the vector, we've got other things than load and save. We've got everything that comes with, and I think we've got to do some kind of we might have to do some public inheritance. So right now we're going to just get the features of inheriting from vector working. It looks like I may have some syntax errors that I'm going to fix. So let's go ahead and just comment this out so that we can get things kind of working before we try to get unworking code working. And it looks like we're good there. Okay, so let's then we're just testing the inheritance portion of the vector and getting that to work. So that means that we want to add items to the vector, and then we want to print the items from the vector. So let's go ahead and do this. We've created our information that we're using for testing, a static array of customers on the stack. So now we're going to create a CList, and then we're going to call this list customers, and that is to instantiate it. And we're going to have an issue here with an error. So it looks like the error is me. Excuse me. We've already instantiated CList, and sometimes I jump between different languages, and I forget what language I'm actually programming in. So what we want to do is we want to look at the vector class, and I think the vector class will have a pushback. So let's just do a quick Google on that. Vector, and you know what? I'm going to pause this, and I'm going to go ahead and get this all flushed out and come back, and we'll go through it. Okay, so yeah, I was thinking of a different language. Here's an important thing when you're inheriting from a class. You want to do public inheritance. So where you're going to go into your customer list object that inherit from vector, and then you're going to want to put this public keyword, and that's going to open up all the vector, the tools for vectors. So make sure you add that public in front of your inheritance declaration up here. And then now we can come back and we can use the pushback function to push a customer onto our vector. And we're going to copy that a few times. Okay, and we're going to push back customer 1, push back customer 2, and then what we want to do is we want to just create a loop that will print the customers that are on the vector. And we're going to use we're not going to use an iterator or anything. We're just going to use the subscript. We're going to use the vector's R value and get that ready to print out information. We should have a customer print function. So I'm just going to call clist print. Clist. We're going to do 3 here. I'm kind of thinking ahead of myself. 3 here. clist of I dot print. Okay, that should do it. So we create the customers, put them on the list, we print the list. Very simple. Then we're going to make that memory persistent with our load and our save. Okay. So let's just verify that, yes, we got our 0, 1, 2. We created our customers and we printed our customers. Now we want to call the save function of clist. And then we know we want to get rid of all this code and just test it by loading it in. Okay. So let's do this. This is where the rubber meets the road. Let's go ahead and do our clist.save. That's our function that we built, which means that we got to go get it working. and let's go ahead and go back here. Now, here's the thing: is now our data in the vector, and this should help you with your string, one of your string assignments. The vector has the data inside of it. It holds its own array, its own basically contiguous array. That's all a vector is a dynamic memory off the heap that's an array, that's contiguous in order. So we want to access that memory, and you can do that through the vector's at function. And the at function will return a specific location in the array. And this is why I like to go from the stack or from dynamic memory to the stack item, so I can kind of see what's going on with that. So what we're going to do is we're going to use this keyword referring to since we're inside the vector's code, we've got so much privileges with doing things this way. I'm going to refer to the vector itself, which is our customer list vector, and I'm going to use the at overload, and that's for a position. So this is going to give me the customer at a specific location. And then I take that information and I write it to disk. So now we are going to set a breakpoint to test this out. Actually, we'll just step into it. Okay, so right there. Okay, so test over. Oh, I did that wrong. Excuse me. Step into. Okay, I just want to make sure that temp is getting the customer. Okay, count should be 3. Okay, we're good there. Ooh, that's hard-coded. No, we got to change that. Count is going to be equal to this size. Now, there's there's size and there's length. Size for a vector one of them refers to how many elements the vector can store. The other refers to how many elements are actually in the vector. So let's see which one this is. We'll have to do this breakpoint. We might have to go to length. Okay, step into, step over. Okay, here's size. We can hover over it sometimes, or add a watcher. You can actually do this. Right click that and say add watch, or you can just hover over it. I believe you can just select it and hover over it too. Yeah, it says 3. So count is getting the right value. So count is 3. So it's correct. Okay, now let's make sure that the data temp is getting the data at that location I. And we'll step over and we'll just examine it. The value is 0. That's the first one. This one should have the value 2 or 1. value 1. There we go. Okay, so I'm just going to hit continue here. And obviously that's working. So let's go here and let's go to the load. And let's do this. We're going to do a little bit of a change here. And we're going to actually test this. And let's not hard code it. Let's refer to the vector size for our count, because this is dynamic memory now, and we'll read in. Oh, we don't actually need. Yeah, we're loading. Duh. Okay, so let's just assign that to 0, because we're going to get that from the vector or from the file. So we're going to read the count of items from the file. We're going to get this information. Then we're going to, I'm going to get rid of this. Yeah. Then we're going to read in the first customer. We know that we need to get 3 in. So we read the first 3 in with our first read statement on line 38. Then our first read is size of customer. Or second read, excuse me. So we're going to go ahead here and we're going to say that customers of I is equal to temp. Nope. That's where we just add it to the list. So we say this push back. Oh, you silly goose. If I can type today. Push back that information we read from the file. Then let's not print it here. Let's just put the information on the list. Okay, so let's go ahead and do that. Build, rebuild. Okay, so I'm gonna go ahead and now we should not need these. These should be on the file. So we're gonna get that out, and we're not gonna save. We're gonna actually load. Okay. Oh, it worked. But let's step through it. Okay, we're gonna step into the load. Okay, first I get right here. I get the count from the file. So that's 3. Then 3 times I go in and I read in a customer and I put them on the stack. So you're going to implement this for your account object too. It's really simple. Once you got it built, you can build an account object from this that saves it also. So you can call it accounts list. So now we go in and we print the customers from the file. And we have our 0, 1, 2 output. It looks like, let's test it one more time. Here's our 0, 1, 2. So we loaded the information from file and printed it. That's working. Awesome. Okay, now let's test the update. Okay, now the update's going to just go in and hard code it, and we're changing record 2. And this is something that you would actually be working on yourself to improve it. It looks like we can choose a record. It looks like we ask the user for a record to change. Okay, then what we do is we open the file. We go to the record number that we want. And it looks like that B minus minus is is purposeful because you have a fence post error, a -1 error here, or a 1-off error here. So we take the size of customer, multiply it by the size, or by B, and then we add size of int, which this one should be size of count, which is an integer. So this adds that 4 bytes. So let's say that I say, okay, I want to change record 0. That means that you want to change this guy. Record 1 will be this guy. So the first thing you do is you want to update this. So the first thing you're going to do is, let's say that we're going to pass it in the value 2, meaning we want to change the second one. So it'll actually be the value 1 that we're changing here, because this is going to be our 0 and then 1. So we say, okay, seek gets, I want to read the information from our second record. So I want you to change from the beginning of the file the size of customer times 3, which is going to be, and let's just pretend customers are 50 bytes, not the 104 that we actually saw. So we want to go for the size of customer, which we're saying is 50, times B, we're going to enter 2, but it's actually going to be 1. So 50 times 1 plus 4. So I want you to move 54 bytes ahead in the file. So seek gets will start from here and go 54 bytes. Well, 54 bytes is 4 plus 50. So it puts the file pointer right here. So now you read that information in. You read the information in. You get that read in, and that read is line 60. After you've changed the bytes or the file pointer to start right here. Then you change the value. That's line 61. This is where you would actually ask the user for information. I'm just hard coding it. So I just set the ID to 999. So then I say, okay, Mr. Record, I'm going to overwrite, now that I've read the information into this data called temp, that's a customer. I've changed that information from the file. Now remember, the gets file pointer is now down here. So your file pointer for getting information and putting information are totally two separate things. So we move the get file pointer 54 bytes and then the read the information, and now the get pointer is now down here. But when we want to overwrite the information, we got to use the puts pointer, the write pointer, and not the read file pointer. So now what we do is when we're ready for our write, we say, okay, Mr. Write pointer, I want you to go for size of customer times B plus size of int, 54 bytes. So the writing pointer starts at 0 and it moves to 54 bytes, and then you do your line 65 write size of customer, and it just overwrites this customer, and now you've got an updated record in your file. And we didn't really have to do much of anything with our vector, but we should. So what we should have done is did an update on our record, and we would have done this. We would have done something like, let's see, since we're 0, 1, we're talking about 1 and 2, we're off by 1 here. What we would do is we would say customer list, or this, and this is where this is kind of awesome. This at function is a function, but it's also got the ability to act kind of like an index. It's kind of weird. I think this is the way it's done. And we'll do this. We'll do at B is equal to temp. So now we update our vector information and we update our file information. And now our update function is done. So you would get information from the user at this point. So let's go ahead and test our update function. Remember, it gets in the file, it does what it needs to, it gets out, rule of thumb. And this is the proper way of doing things than the inventory program. But remember, you got to do things wrong before you can do it right. Okay, first thing we do is we load. Now we're going to do is we're going to do a clist.update. Okay. We're going to do record 2. And there's our record 2 changed. Now let's go ahead and just load it without the update. and our record 2 has been changed in the file. So you now have persistent customers that are dynamic. And you can use this. Now what you can do is, this all works good. You can take this customer list and make it an account list for a vector of accounts or savings. But more on that later, because in the future, as we're working towards dynamic binding, you're going to be saving accounts, but you don't know what type of account you'll be saving. So the sizes will change. So I'll have to, your file header will need to be more significant as you work towards your project and implement dynamic binding. But we kind of don't really expect you to get that dynamic binding part done. We expect you to be working towards it and actually getting it to work in 260. Okay, so this is my example of dynamic list of objects that are persistent. So you can build a menu system now, save customers, load customers, have as many customers as you want to make this work out for you. Okay. We're going to go ahead and hopefully I haven't talked too long. Some of that's from pausing. So thank you. Goodbye.